Awesome. Thank you, Leslie. And with that, it's my pleasure to introduce our lovely speakers today. We have our opening speaker, our Yahash Yadiya, technical enablement specialist, speaking on fine-tuning open source models. And then we have our closing speaker, Sandesh Gwande, from our CTO and founder of iceDQ, speaking on data testing automation for big data and AI, lessons from TSB bank migration meltdown. So it's a mouthful, but it's a really cool case study nonetheless. So with that, we'll have our first speaker come to the floor here today.
Good evening, everyone. It's quite a strong turnout. I was quite impressed at how many people were here to talk about open source fine-tuned models, but then I realized like it was on DevOps Cloud on top. So nice surprise. I'm Yashis. As I was saying earlier, I work for a company called iceDQ. That's a mixture of data and haiku. It's a French-American now scale-up that's been in the data science, ML, and then AI space for a while. And we do an end-to-end platform where you can do things faster, easier, all of the same promises. And now that applies even more for AI than it did previously. I'm actually here in a more, let's say, open source capacity to talk about some things I've been playing around with. And so that's what I'm here for today, which is to tell you about how to train a model to respond like ChatGPT, or at least try. So first off, the acronym I'm using for DS is for a data scientist, and I know we're with some DevOps folks, but so as I was saying, the acronym on the screen is for a data scientist, and I know we're with DevOps folks, so hopefully this will still be relevant for the crowd. Essentially, this talk is a bit about like the journey I've had in the last, let's say, decade or so, going from sort of the frozen tundra of academia being a bit of a transition into machine learning and data science, and then kind of redoing and relearning that all over. So essentially, when I went from academia to sort of the industry of data science, people ask me like, what's different? And what I tell them is, oh, like, it's all just done on a MacBook. Like, it's just the same old statistical models, but now it just runs on a MacBook. It's a PC or let's say Linux system. And what's fascinating to me is that over time, like people kind of learn about their scikit models and their PyTorch and Keras. And soon we find ourselves like really in the age where it's just now LLMs all over. Right? And these are LLMs that you call using APIs that are hidden behind lots of layers, lots of walls. Hopefully, some of them are going to be hosted by folks like OpenAI, and then they kind of democratize the field. But really, in a way, for some of the technical folks maybe here, you're facing this like almost existential question. Like, what am I doing? Like, I don't train in models, just write API calls to things, and that's the end of the day. And so it really got me thinking whether or not, like, the data scientist as a species is going the way of the dinosaurs in some sense, like, and what that evolution might mean. And so, I thought maybe there's still hope, right? Like maybe there's still ways to use sort of open source models and really get down to understanding how to train them in that some of these more, let's say, bigger companies use them to get the kind of responses that you might get when you use a provider of OpenAI or application like ChatGPT. So essentially, that's kind of the journey, and that's kind of the process I'm going through. And what I'll do today is quickly introduce the place and like where I am and what I think of the audience, and do maybe a quick understanding, a quick poll. And then we'll go over like what we could do with LLMs at this point. Like, what are the things you see done, and what are some of the techniques that are being used to make them as effective as they are. And then finally, we'll quickly go over, and I will actually leave some time for an actual technical demonstration to show you how easy or difficult it might be to do some of this on your own on some very accessible like infrastructure and some very accessible, let's say, resources. Okay, how's that sound? Sounds a bit better. Got it. Thanks. So as I was saying earlier, I really found myself about a decade ago from the frozen tundra of academia in the industry of data science. And to me, it really felt like I was trading some of my hard-learned skills into some very different skills. So very much so going from statistical analyses to very much the world of like MLOps and endpoints and streaming and so on and so forth. And it was a very exciting journey for sure. That said, I sometimes still kind of find myself wearing that hat of really finding some of these very initial hello world examples, which is what I mostly do in my day job still. It's like really work through lots and lots of examples to understand like how different frameworks work and what's behind like maybe a new fancy package out there, fancy library there. And very often, like I find that maybe these hello world examples are not written in the most clearest way possible, or maybe the most accessible way possible. And that's definitely a passion of mine to try to get better at and also get more of an understanding of. What I was going to ask of the audience, if we were at a purely AI sort of meetup, was which of you guys have done all of these or any of these two things? But maybe I'll take a step back just so we understand the audience a bit more. How about we break it down into first data science, ops, DevOps, infra ops, and then other. So everybody in the data science, ML, and AI world, would you mind raising your hand just so I jump in? Okay. What about the ops folks? And then other? Okay. Okay. Well, that said, then maybe this poll is probably applying to only a subset of the folks, so that might make more sense. How many of you have tried setting up a retrieval augmented okay, sure. Awesome. How many have tried like fine-tuning models? And anybody tried reinforcement? Well, you want to teach me a thing or two because I have a lot of questions. Okay, great. I would say that they're all great methods, and clearly, I would say probably RL seems to be a bit of the secret sauce with like which some of these things are made. But that's what it was a really good sort of intuition or understanding for me while kind of going through the thing. So to come back, a lot of us, I will not go over the preliminary, these are LLMs and these are what they do. There are a lot of language models floating out there, but they're limited in their own sense. Talk about that in a second. Something that really helped me understand like this, and I actually attribute this to a former colleague of mine, someone who's in the team and now works at Mistral, one of the other LLM providers, is basically you can improve and customize models in two ways. You can either improve the knowledge they have. So in a way, what you're doing with RAG is like, kind of making the model better by giving it more knowledge to base whatever the generation is from. And then you can kind of tweak their behavior a bit and make it better or more adaptive to what you're trying to do by fine-tuning them. And in a way, I see like RLSF as more of an extension on that side. So maybe it's even better than just regular fine-tuning, but it's on that side of the house generally. So as RAG is to knowledge, I see fine-tuning as to the behavior. And in a very basic sense, like that's what kind of the working principle of this talk is. So going to the what, of course, and going back to that, essentially, like as everybody knows at this point, LMs, like RAG is something you should definitely do, but there's none of that in this talk. So maybe come back another time and we'll talk about that and kind of go about finding some material on that, because that's also a very important technique to be aware of and very much in vogue. So, on that point, like, why do we want to do things? Why do we want to make them better? Like that's essentially the purpose of like all of the work that I'm doing and you guys' experimentation. And part of it's simple. Like this is a bit of a, let's say, analogy from causal inference or the world I was in, which is that LMs are very much training and or LMs are very much limited and based on their training data. So this was actually earlier on in the year when I was doing some of this exploration. Sometime in August, I asked ChatGPT, obviously, who was the Democratic candidate for president. And this was well after it was announced, but because again, LMs are limited by their training data, it really thought, well, even as of August 2024, Joe Biden was running to be the president for the Democrats. So when it comes to LLMs, you always have to augment their information, and that's how it goes. Like that's just standard. What this means to me is that even though we think about, and I'm more from the sort of like almost time series school of ML, where you would think of models as being predictive, but GenAI is very much general. It's not really predictive of anything outside maybe of the training set itself, right? And that's something to be aware of and in a way limited by. What this does mean for practical purposes is that, and very much everybody's described this, right? They're giant black boxes that seem great at completion in somewhat random ways. But are they really that random, right? So let's kind of just do, so I don't go anywhere without my ID, clearly. I feel very, very alone without it. So let's do like a simple code. Like I recently had a baby, and I find that, I'm singing nursery rhymes to my newborn all the time. And after singing the same nursery rhymes maybe 10, 15, 20 times, I'm like, give me a variation. This is very, very boring at some time. So I wrote like a prompt, and in this case, I'm going to hit up like a really old model, like a Da Vinci 2.0, which is like, old by standards of today, just to help me rewrite this rhyme where I'm telling it to write a nursery, right? And so I say, okay, write me a nursery rhyme that goes like blah, blah, black sheep, but write it with the llama instead. Long's not very good at this, especially at that age and at that, let's say, vintage. And so the point simply is that, they seem great at completion, but they're really just repeating what they already know. They're just like spitting it back or generating or predicting the next word in the same way. Also, a side note, a bigger note, and a more ethical concern that we will not go over today, even though I know that, like let's say the DMV area, LMs are giant block boxes that are great in completion, but biased by their training data in often very, very troubling ways. And we know that, we've seen plenty of examples, and there's been a lot of work to remediate that. RL is actually part of that. But that's just the way it is. When your data is trained on the internet, it can turn out in very, very strange ways. So there are several things we can do, and this is by far some of the most helpful, let's say, visuals I've found. These are from our friends at OpenAI when they kind of introduced the technique called reinforcement learning human feedback. They kind of gave this diagram of 3 steps, and I'm actually going to follow these steps closely. And actually, the framework I'll be using kind of just separates out the task in these 3 steps, so that's even easier. Essentially, they start by doing fine tuning, which is the most common way of like improving the behavior of LLMs, where what you end up doing is and for more the ML folks amongst us, this is more like supervised learning. You give it a set of like responses, and you train the model to be more and more like that in its response. So you give a desired set of responses, and let's kind of think about this. Then that's used to train the model. So I kind of went and did this. It's maybe not the best example, but I fine-tuned one of these models using some poems. So now I was like, okay, what's the closest thing I can get to nursery rhymes? Let's like train a bunch of, or train a model on a bunch of poems and see if it does any better. And I mean, I could probably sing this to my infant child, but it's still not there. And that's not because maybe it's the fine-tuning's fault, but it's because I didn't really have good data to begin. So for fine-tuning, what you really need, and I only have 1,000 examples or 800 examples, maybe you need something in the order of tens of hundreds or millions, if helpful, to really fine-tune the model to respond in the following way. You tell it something, you see how it kind of responds, and you kind of prompt it more to respond in a very certain kind of way. So basically what you need are these pairs of prompts and responses, and that's like how you fine tune them. Now, RL takes this a step further, and this is definitely where for the RL folks here, I will definitely ask you questions. I struggled as a almost caveman data scientist because I was more aligned with the training models using some, let's say, scene data or some responses that I'm familiar with or have been labeled. The good news first is that it's getting increasingly popular and a lot of people are talking about it. There's tons of papers, but also entire repositories on GitHub where you can go read different kinds of frameworks that exist, get the data sets that are required for this kind of training. There's several like awesome GitHub repos that are really great. Whenever I'm learning up on a subject or just need to find some frameworks, that's where I often start with. And these are also maybe because of the audience or the people I follow, like showing up more and more on my LinkedIn posts, like, oh, this is what you need to know, and so on and so forth. So obviously we'll go back to a final example because the models that you've been interacting with, say in ChatGPT, are very much now of the variant where they have been strongly, let's say, reinforced with human feedback. So I will go to, let's see, the other. So now, I can actually give it a lot more context. And if I'll have to put this down for a second, sorry. So now the prompt is a bit more specific and like I can actually give it the same general prompt and say, okay, write me a nursery rhyme about a llama. So it does go Baba Black Llama. It's very much the same. And it at least tries or attempts to get at this. And it's very much because like it's gotten, better over time with the training. And hopefully, we'll start by showing you what are the steps to follow to get there. Of course, we're not OpenAI, so we will not be burning lots of money doing it. The bad news is that if you're a caveman DS, maybe you are still, running traditional models. Maybe you're still working on some of the traditional ML like I am. Custom LLMs are actually pretty hard. I mean, that's kind of the reason why they're super specialized at this time. And so I found, here's what I sort of did to try to implement something very simple. I found a framework called DeepSpeed, and you can find the Hello World example on DeepSpeed examples. And there's an actual application where you kind of go from the first to the last step. Because I was on my personal time, I actually used Google Colab Pro, which is a very simple notebook infrastructure you can get, where you get a notebook on top of a CPU or a simple GPU. And you can get that at collab.research.google.com. For the specific DeepSpeed framework, most of their, let's say, scripts are actually for much bigger models. And I realized, well, I'm not going to run that on my own, burn hundreds of dollars, even on Colab, that would probably end up happening. And I'll show you some estimates that they provide. So I actually rewrote a lot of that script for the smallest models to begin, because again, I come from more of that ML background, try to get the simplest model running first, kind of go from there. So I trained it on a 350 million parameter model, which is very, very tiny. And I kind of wrote all of these commits down, in my own GitHub to remember, okay, like what were the changes necessary to the framework. So that's what I've done. And I'll kind of show you quickly the RL steps. And then I'll actually open up Google Colab and I'm watching Josh for the time, just to show you how maybe finicky it is compared to like a VS Code and how to get some of this stuff in there if you ever want to play around. Because for personal like projects and fun, it's actually pretty easy to set up. And that's the thing, maybe it's anthema to say in a ops co-meetup, is I'm terrified of setting up infra and just spending hours and hours trying to get things and have it all burn down. So, maybe I can talk to some of you about it. Okay. So the RLHF actually picks up really and is different from the second step, right? So if we're going back to the to the helpful diagram we have, essentially what the difference is that not only do you have, let's say, prompt in this case about something like the one I showed you earlier, you also have like variant responses. So essentially, and in my case, I just did good, bad. So you have like a good response and a bad response. And that data is actually used to train a much smaller reward model that gets like ready for the next step. So we basically train and store a reward model that favors the better response. The better response is obviously, sorry to go back to the example, human label, right? Like that's the human feedback in that RLHF loop. So you have the human preference, and then essentially you train a model to recognize the difference between a good response and a bad response, and to like start to change its weights in order to favor the better response. What that gets you essentially, or the way that's implemented, is first you have to actually prepare the data, and this is something I can go over in a little bit. Like you have to have like preset data sets that have prompt, winning response, losing response. And then you actually generate scores and then calculate a loss function to train the reward model. The end output is a reward model that can now score responses based on their quality relative to a given prompt. That you carry over into the third step. And now you kind of start to almost like generate responses from prompts alone. And this is a bit more, I think, better with the conceptual idea of basically combining that fine-tuned LLM from step one and the reward model. And what you're trying to do with PPO, which is an algorithm, and there's actually others out there, but like I used basically the one I could implement the easiest, where you generate high scoring responses according to the reward model, but you also still try to like maintain performance by kind of making sure that the model performs well as according to the original fine-tuned task or the pre-training task. So essentially the output that you get in this case is a new LLM. So you get a new model that generates responses optimized to maximize the reward from the second step, but balanced by yet another predict model that kind of keeps it in line with what the fine-tuned responses are supposed to be. That's a lot of words. So maybe I will show you some results first of the differences. Setting any X out of that. So if we're looking at just step one, and I'll point you to an example I like. So step one, very small model, like really, basic at the end of it. It's asked to explain a moon landing. And these are like, you can generate these responses at the end of every training model, like every training step. So you can do a step and you can say, hey, like, show me what these responses would look like between one and the other, which I found very helpful because what is a model without the actual output it produces? So, the first one is quite helpful because you can see that the baseline model, basically craps out by saying, I don't know what you're talking about. I don't know what you're talking about. And with LLMs, a very frequent thing is hallucinations are their own thing, but repetition. They just go into some kind of loop and they keep spitting back the same thing over and over again. The fine-tuned model, on the other hand, at least makes an attempt of it, even though it kind of totally, let's say, screws it up by saying something untrue. And so here come the hallucinations. But at least like it knows that it's trying to get you to respond in like, because the training data has shown it, like it's looking for some kind of essentially assistant-like response. What's interesting, or what was helpful to me, was that I could look at the same now responses from the fine-tuned model, whereas the, again, reinforcement learning model did a much better job of summarizing what was there in its own training data, and at least giving a more, again, response that a human would prefer, right? And I think, and this will be very interesting to talk to Josh afterwards, this is the thing I find fascinating about LLMs, is like a lot of the sort of evaluation is basically taking some of the responses and trying to understand, like, did it do right? Did it do good? Did it do what it was supposed to? Some really obvious things that I said earlier, let's say like sort of emphasize again, infra is definitely going to be a bottleneck with this. So slowly we're at a DevOps sort of side of things, because to me, as like, somebody who was a caveman data scientist, graduated to at least thinking about MLOps and setting up things like that, this is definitely another kind of step forward. The frameworks, TSB included, and again, I went through a few of them, are rough. Like they will not work all of the time. They're being updated and they're being sort of committed to all of the time. So like keep watching the repositories. So even the example ones, the same thing. You might even be able to commit to them because like there's definitely room for improvement. The results are promising given a tiny model and a very short loop. I'll show you what they estimate for an actual, let's say, real model that's about a billion parameters, or maybe better around the 7 or 8, is that the entire process could take anywhere from, 1 day on a very simple A100 or GPU to maybe several days for larger models. So that's just like how it goes. Okay, great. I've 5 minutes. So first, thanks for listening. I'll open up to questions at the end of 5 minutes. I'll just show you quickly what the lay of the land in the Google Colab looks like, because I think that was the most fun to me. And if I can get that down and get that out. Okay, great. So Google Colab okay, first also, has anybody used Google Colab more extensively than just the first? Anybody use Google Colab? Okay, cool. Nice. So again, this side of the house. What I obviously found was, let me replicate this and then we can kind of create a copy and I can start from scratch, right? So essentially, I'll keep this close by so it at least modulates my voice. So it's a notebook built on top of a set of infrastructure. I can connect to different kinds of infrastructure resources. It tells me roughly how many compute units I'm using, which is good, helpful. I can then basically change the runtime type. Essentially, like, you have to use at least an A100 to train even the most basic model, which makes sense. That costs you around like 10 units. You get like roughly 100 units for $10. So it kind of maps out to like at least a good training run. I was able to complete most of it. That's the only good part, maybe, I would say. Of course, it's going to be much harder than setting up your usual like environments. So let me see if I can. So what I ended up doing, because like this happens, is and this is the thing about a Google Colab notebook, is it's not persistent, right? Like it's not persistent infrastructure, it's running everywhere. So I ended up just putting most of my stuff on GitHub and then literally going in and kind of cloning my repository over and over again. So what I have to do is find root, find my SSH, put my keys. Don't look, guys. I know the infrastructure folks are going to be like, what are you doing, man? You're killing us. Let me get off soon. I know. I get crap all the time for this. Like 2-factor authentication, all of the good stuff at work. But when it comes to this, I'm just like, let me get this done. I need to really just get this done. Okay. So again, like the thing about the runtime is like your files will be deleted. So you have to find a way to keep these files alive, right? So now we can go back. So now I can actually get access to my GitHub, hopefully, yada, yada. Yeah, this is how I end up writing most of my like tutorials, is because I start to do something and I'm like, these would be really helpful to write down. Okay. All right. Nice. So it doesn't come with virtual environments. You have to install them. So I'm actually going to skip that. So there's a thing called deep speed examples, which is what I'm using. And I will check out the relevant branch. And I will close this. Okay. Sure, it looks terrible, but that's the thing about the Google Colab. It is not a true ID for the people who love their colors and their emojis and all of that. I think I can share desktop. Yeah, thanks. Okay, hopefully you can see some of it, but thanks. Okay, so essentially you have to install your entire environment over and over again, right? So we're going to go install all the dependencies. Hopefully it doesn't break, because who knows, every time is a bit of a lottery. And essentially what you can do is, the process like I document for myself is, okay, how do I set myself up and running with the most limited number of steps I can? And so I can at least get to the initial training steps. And to be very honest, I think it's good for like a very basic example, and that's what it was for. I wanted to run this framework somewhere that was not work infra, because I didn't have access to it, my nice AWS console or all of those keys. So it's good enough for that to begin with. And now, like, hopefully that's a thing. As a next step, I can actually think about, okay, what do I need, and so on and so forth. So I encourage you to at least try it out, because $10 is half a ChatGPT subscription. So if you're burning money on that anyway, you might as well find out what's the secret sauce behind it. So I will get to, I think, step 1. Hopefully, if I can show that it runs, then that's a bit of a demo. That's my goal for now. Packages are the thing that terrified me the most as a data scientist. I think the instability of the Python ecosystem, sometimes, especially when it comes to the deep learning stuff, is scary. So hopefully, like, CUDA installs fine and all of that. You're a bit worried. It's as long as it doesn't go on a loop, I'm okay. Oh, but I have to. I'm not, I mean, there's no option, right? I can show you the other thing, but then the point is also this, right? Like, how do you actually, as a regular, let's say, data scientist who does all of these things in your personal laptop or your personal like sandbox or work sandbox, how do you actually get outside some of this stuff? Pip installing is not a good idea in a demo, I now realize. Centuries, I know. ... Anyway, let me go back to the main, the one I had running, essentially. So what's nice about, like, once it's done is you have like a ready-made environment where you can just run the deep speed examples step by step. So like I said, you have step 1, you have step 2, you have step 3. What you need to do is, I'll go to the end step, you specify what kind of model you want to use, what kind of deployment you had, and I had to rewrite some of these scripts a bit. So this is why I was like, that's the commits I actually made. And then you kind of just run it step by step. And what it does in each training run, and I think my training run has been killed, so we'll see what happens. Root, deep speed. Nope. That's the other thing, is it's not persistent. So you close your computer, it kind of goes away. Oh, it's done here. Okay. We're not dead yet. Those should be a little less heavy. I think most of the dependencies are already installed. Yeah, it's a framework that Microsoft open sourced a while back, and it's definitely like gotten better. What I like about it is that they like also have an examples repository, which again, to me, like the hello world is very important in this, because sure, you can have like the whole like, kind of big model training in the actual repository, like they have the let's say like script to do it, but I wouldn't be able to run it on this machine on even like this thing, right? So there's a second repository called Deep Speed Examples, and there's a couple of applications they make from that. And you could actually, at the end of the run, take the model and then like go from it altogether, right? So this installs deep speed. And essentially all you need to do at that point, and this is my favorite step as a DevRel, is say, then you just run these 3 steps and then you have a model. Obviously, we run them and we go away and come back in maybe like an hour or 2 or what have you, but that's at least doable. So that's kind of essentially what I did sometime this summer while I had some time on my hands while the baby was napping and I was running a few errands here and there. I will stop now.
Okay. So TSB is one of the biggest bank in Europe. They got acquired by another company customer. So the project is not really big in the sense there were about I think 5 million customers you have to migrate from one system to another. But then what happened, if you look at this, is 1,300 customers during this migration. After the migration was done, 1,300 customers lost their money, right? They had to go on Facebook. Imagine a company going on, a bank going on a Facebook and saying, "Oh, we are sorry, we are losing your money. You can't access our system," right? So this is what happened. Then, if you look at this, the TSB bank was fined like 48 million pounds by the agencies, and the CIO. What is interesting here, the executive who was running this project was also fined personally, independent of the company, right? The report says they lost about $330 million in the project, and to tell you the truth, the number is somewhere closer to like $1 billion. They lost about $1 billion in this whole migration project, and a very simple reason that when you do projects nowadays, many of the projects are data centric, right? So people think a lot about application, DevOps, how to build code, how to deploy code and all that, but they don't focus on what to do with the data. Or data will automatically follow, right? It doesn't. You need to take care of it. So this is a good example, and it's a very well documented. Is all these records are publicly available, so you can question anything that you have. You can find it online. So there were a few other reasons: unrealistic deadline, communication breakdown, project complexity, external vendor reliance, and then this is the point that we are going to talk about. In this whole 5 million customer migration, they didn't have any data testing, they didn't have any concept data testing, they didn't have any data test automation. There was absolutely no focus on data testing. So if you look at the project point of view that we are going to cover, is one of the things what they did is such a huge project. There are financial dollar amount involved in this, and when they did the migration, they did very tight, 10,000, and say, okay, we did this 2-3 samples. Now let's take the complete data set on some 2018 Sunday 22 and migrate all the data in one shot, right? And what is going to happen, right? Instead of the whole issue here is you just can't do small migration and then do a big bang migration and see that you have all the data in place. It doesn't work like that. And one of the things that hindered their this migration was the sample size. And the reason they use probably we don't know, but the reason probably they use such a small sample size to do the migration was they didn't have any automation tools to test that much data. Because as a human being, you can check 100 records, maybe 1,000 records, but once you cross that 1,000 number, within millions and billions, there's nothing you can do about it. This another interesting point from DevOps point of view, and we call it data ops in our world. But the point is, they were upgrading while they were migrating the software. They were also upgrading the software. Fine, you test it, but at the same time, they were also migrating the data also in the same system. So you are migrating data from a stable system that is working. You might not like it, but it was stable, to an unstable system, and you are saying, "Oh, I'm going to test it." Like if you, it is expected versus actual. What is in the source is the actual, and what is expected in the target. But since the data model and everything is changing on the target side, you can never succeed into an unstable system. So the one other point, if you are in data engineering, is if you're upgrading software, think about data testing and don't make them happen simultaneously at the same time, right? Another aspect of this project was confusing ownership. Since there are so many components in the system, the companies didn't decide like who is going to own what. And if you look at the testing of data migration, there are multiple owners. And you know what? When there is joint responsibility, it's nobody's responsibility, right? So that's what happened over here. Another key aspect when you are doing data-centric projects is a data warehouse or a data lake or a data migration or big data, right? You don't create the data. The data comes from somewhere. Somebody provides you files, somebody provides you data, right? And then you load into your system and then you process it, use the data. So if you don't understand the source model, the source data, you are not going to be able to capture the essence of data. You are not able to going to store it properly. So in this case, they didn't have the access to the source system or the data model from where the data is coming. So fundamentally, they didn't understand what they were looking at. And they tried something that you don't understand on source system. You are trying to migrate to a new system that is unstable. So that's another big failure. So this is another interesting, very interesting. So a system, and I can go into details, but depending on your patience, but fundamentally, when you migrate, there is an initial state, and then when both the old system and the new system are in sync, then you do transaction on both sides, right? So they only checked while testing and development and migration, they only worried about the initial state migration. And so what happened, if you look at this, you have the legacy system, you have the new system, you create the models, you compare them and say, oh, everything is good. Then you load incremental data into the new system and make sure that the incremental data is correct, right? The second phase. The third phase, I know I'm going a little bit faster, but hopefully you'll catch up. The third step is important, that you do the same transaction on both sides, the old system and the new system, because your system has changed, the model and the business logic has not changed. So if I had $100 in the legacy system and $100 in the new system, so if I had to add $4, it should be 104 and 104, right? So they missed this step. They didn't do this testing, and then you have the chaos, right? So delta and upgrade, if you don't do it, it doesn't work. And one of the reason, like I want to bring this up, is if you work in banks or insurance companies or any of these big, regulated industries, this you will see this problem again and again. It's not necessarily that you're going to do tests, but these are some of the fundamental questions that you need to ask these people, to the teams, to the developers, to the management. What are you doing? Are you doing this thing? Are you not doing this thing? See, another problem here is how many of you heard about chaos testing, chaos experimentation? One, chaos experimentation. Yeah, somebody came up with this idea, right? So basically, what you do, there's a big system, very complex system, and you pull a plug on one of the system and see what happens, right? how it responds. Now, forget application for a moment and come to data. When you are doing huge data projects, you don't have one record or 1,000 records. You have millions of records, billions of records. You have not one. You have customer data, you have transaction data, and all kind of data. So when you do a migration or you do testing, the mistake often people do say, "Oh, I am going to define all the test cases and all the sample cases in advance," right? And the problem with that is you are going to miss the data, because the use cases are actually discovered from the data itself. In data, you cannot identify all the use cases and test cases when you sit and think and you know all the business logic. You are going to discover it from the data. So one of the things they did is they didn't use enough pre-production, enough data in pre-production to discover these use cases, or what you call as chaos testing or chaos experimentation. So we want the data to give us the test cases or the use cases. Another interesting, this is like the so there is a main migration event, right? And then there is a data migration testing, right? So this is one of the, in a data migration project, data migration should be key, right? But they did not even, before they went live, they didn't finish the complete migration because they never planned. They never gave enough time for migration testing, right? Another problem is, again, as a human limitation, you cannot test more than few thousand records, right? Maybe 1,000, 2,000, 10,000, I don't know. But beyond that, you can't. So you need some automation platform for that. And if you look at this study, they had Jira, they had HP Quality Center for requirement and test case management, and maybe some application testing, but nothing for data testing. Okay, so I stated all these problems. Let's go to some solutions, and I'll try to get some of the ideas of data testing concept, data reconciliation, data audit concept into this talk right now. So this is how much data is generated every day, right? In 2010, it was 2 zettabyte, and now to 2024, it's about 181 zettabyte of data every day is generated, and there's a source for it. So you don't have to trust me on that. So 225, and if you look at this, it is just increasing. It's like a rocket on a booster. And if you look at this, like you say, oh no, we only deal with applications, we don't deal with data. But if you look at CRM system, they are basically data applications. If you look at ERP systems, Workday, SAP, they are basically data applications. If you look at e-commerce applications, they are mostly data related. Trading platforms, marketing platform, what is there? It's all data, right? Social platforms. So as more and more projects you do, the more and more you realize that you are actually dealing with data. And if nothing in this, I want you to have one takeaway from this, talk or meeting or meetup is, regardless of how big or small project it is, you have to think about if is there a data component within that project, and give importance to it. And this is just some examples. So what we are talking here, those are some of the applications, and then these are some of the projects. Like we have data warehousing projects, ETL pipelines, data migration, cloud migration, system migration, big data, data lake, BI reports, AI testing. So there are a lot of these. These are all data projects. And the question, as I said, once you understand there is a data requirement. So if you look at a data-centric project, the same SDLC principle in whatever format you implement are still applicable, right? There is requirement, there is design, you can do agile coding, and then there is a testing, and then there is deployment. You will have some modified version of this, but basically these things don't go away. If you look at this, remember what I said a few minutes back, right? Is this a data? You have to ask this question when you are doing this project, SDLC. Is it a data centric project? Yes or no? Right? If it is data centric project, are you going to do testing or not? Right? If you're going to, because no sane person will say that we are not going to do data testing, right? Then the next question is, in 2024, are you saying I'm going to do data testing manually? I'm going to write scripts, right? So that is the next question you need to ask. Then the last question that you need to look at, if you are going to automate data testing, are you going to build something in-house, or are you going to buy? So buy versus build, I don't want to go into the discussion, but it is a common sense that you don't get into this. Your business is to run the business, not build tools and components to run the business. Yeah. So this is many people wonder why Sandesh is here and we're talking about data testing, right? And the reason is data testing is very different from application testing. And these are some of the points that I wanted to bring in front of you. Is in application testing, you have user interface. Like, so there is some UI where you play and click and do something happens, right? Yes, no, and there is error or something. But in data testing, there are no screens. There are processes running in the background in the engine that run and that take data and process it. In application testing, there are few transactional records, like you do a $4 transaction and check everything fine or not. In data testing, there are millions and billions of processes that are running, is being processed and loaded into the system as part of your job. There you test code. Here you are testing the data process or data pipelines. The skill required here are scripting in application testing. But if you go to data testing, then it is SQL based, right? Or something similar of that. And the point here is, in application testing, most of the corner cases are documented by business analysts, but the corner cases which will make your project failure or successful in a data-centric projects are discovered by the data itself. You go through the data and you discover those test cases or use cases. I hope this is useful from a thought process, for all of you. I'm going to try to wrap up with this. Once we understand that there is a difference in application testing and data testing, the next question is, how do we exactly do this? Like, what is the process of doing data test? The way it works is, and this is a sample example. This is not exactly true, like this is how it happens. But in general, it is true that you get some files, you store in a data lake, then you load into a data warehouse. They go into either extracts or data marts, right? Then these data marts and extracts, they actually go into some kind of reports. Now, for our point of view, and this is important, so how data testing happens is, if you look at when the data is when you receive the data, you need to do tests to make sure that the data and the format that you receive is in the format that you wanted. So that's the first test, the source data validation. The second test is, whatever I received 100 million records, did I load 100 million records or not? So that is what called source to target reconciliation. That's the second case. The third case is, once you receive the data, you just don't load it the way you got it. Sometimes you multiply, sometimes you divide, sometimes you filter, sometimes you aggregate, sometimes you integrate. So you need to create rules to do the ETL reconciliation, the transformation. You need to verify that the process is transformed the way you received it, right? Then, but these are technical, right? Based on predetermined rules that you know that this is how the process should work. But think about this. If I say, I have orders and I have shipment, can I ever do shipments without having orders? I cannot, because I need to have order for shipment. Now, if I do just the technical test, I won't capture that, because if I check the order pipeline, it will be correct. The the shipment pipeline is correct, because it is possible that you never receive the orders, so you can't do this. So the next step is, in the thought process you have to do, is what is called as business reconciliation and business validation. So the BAs, the business analysts of the users, know that my discount cannot be more than 5% or more than 100% of the price. So you put those test cases within the system, and they're called business validation. So that's how you test data from that perspective. Then you cannot ship without having an order. So you can do business reconciliation, where you say, hey, you cannot have shipments. Show me a shipment for which orders don't exist. Now, this is business rule. This has nothing to do how you transform the data or what you did with the data. They're universal, at least for your business. And then the last one we have is the report validation and the report reconciliation. So many of these data is used by CIOs and CEOs and presidents to report to the management or to the customers or to the investors. And you need to reconcile these reports with the actual data in the database, otherwise you have problems. So these are some of the ways that you can actually test and validate a data pipeline. Sorry. Thank you. And I appreciate your time. And this is like, this is not so spicy subject, but it's something I wanted to give an insight and come and talk to you guys and share, my thoughts on data testing. Thank you, everybody.